So, Eric, welcome and thank you so much for taking the time to join us here today. I'm really looking forward to an insightful discussion with you around data modeling for industrial IoT. So, welcome.
Yeah, thank you for having me. Great to be here.
Awesome. So maybe for those who don't know who you are, can you please begin by introducing yourself and your work to our audience?
Sure, yeah. So my name is Erich Barnstedt. I'm the Chief Architect for Standards, Consortia, and Industrial IoT in the Azure Edge Platform team. I've been with Microsoft for 20 years, mainly in the manufacturing space, certainly more than 10 years in the manufacturing space. Before that, I was involved in the automotive space. But in terms of Microsoft teams, I've worked in the server team, the Windows client team, embedded team, automotive team, and then for the last 10 plus years, I've worked in the Azure team.
Awesome. Yeah, I mean, so now over the years, you've done some incredible work around the concept of data modeling for industrial IoT. So maybe can you begin by explaining why data modeling is so essential in the context of industrial IoT?
Sure, yeah. I mean, we started off bringing assets to the cloud, over 10 years ago. And obviously, when you start off bringing those assets, those digital twins of assets into the cloud, you need to create a data model, right? And we found that at the time, the OPC UA standard was just, becoming widespread and popular. And of course, we could have come up with our own data model. Quite honestly, a lot of people do that, right? But our customers told us loud and clear that they don't want vendor lock-in. They want a data model based on an open standard. And we picked OPC UA because it was the most obvious choice. It's now, in our opinion, the de facto standard for industrial asset modeling. And, quite frankly, everybody loved it and it became our differentiator in the market. So that's why we picked OPC UA. And again, I mean, if you want to do anything with an asset in the cloud, you need the foundation is always the data model, right? So you want to get the data model sorted out as quickly as possible and ideally normalize all the data to that data model on the edge such that, by the time you send data to the cloud, it's all in a consistent format and you can do analytics across all your assets and all your sites worldwide, right? So that makes it much easier rather than trying to, bring all the data together in the cloud and come up with, a unified model in the cloud. That turned out to be, we tried that too. It didn't really work out that well, especially when you start scaling to large manufacturers. So we decided it's much better to do that on the edge and then send the data and the data model. So first you send the data model to the cloud, you store it, and then you can send the data along with it. And that obviously, is easy then to figure out what data model it belongs to and so on. And you can run your queries accordingly. Yeah.
Awesome. Now, generally speaking, or maybe more specific to OPC UA, what would you say are the key components that make a data model suitable for industrial IoT application?
So especially in industrial applications, you need several things. So first of all, the data model needs to be, easy to work with. I mean, that's something that, also depends a little bit on the ecosystem that's available. So with things like OPC UA, you have a large ecosystem of companies that have data modeling tools for OPC UA, so that makes it easier. And then, of course, the features of the data model itself, it needs to be serializable, obviously. It needs to be fully featured, so it should be able to model, tags, alarms, events, methods, references, so you can create like a graph. So OPC UA is basically a graph, so you can have references in multiple dimensions in your model, right? And then, of course, you need to be able to have good tools available that allow you to map from other models to your model, right? So that's actually another reason why we picked OPC UA, because there's a large ecosystem of industrial connectivity providers that also have provided OPC UA servers in their solution, right? So you can start modeling your assets, whatever interface or data model they may use in OPC UA, and then the solution, the tool, whatever you want to call it, the edge components, usually runs on the edge, can do the mapping for you, right? And in fact, here, I'm just about to start off a new working group inside the OPC Foundation to not just standardize the data model, and then as a next step, obviously also the telemetry format, which then flows from the edge to the cloud, but also the interface, the configuration interface for those mapping software and for those industrial connectivity software, because right now everybody has their own control plane or their configuration interface. And if we also standardize that, obviously that would also create a big boost for the ecosystem to integrate those tools more deeply and more complete. So that's just about to start in 2 weeks from now. Happy to have HiveMQ participate.
Awesome. Yeah, that's really interesting. And would that also include configuration for OPC UA PubSub? Because I've had recently questions about someone who watched one of my videos on OPC over MQTT, was asking what configuration tools are available.
Yeah, so most of the existing solutions that support PubSub use the standard OPC UA mechanism for configuring PubSub. So it's built into an OPC UA server, so you can use that interface. My particular working group won't cover that because it's covered in the UA working group inside the OPC Foundation. But that's already been defined as part of the standard. So how to configure PubSub is part of OPC UA already. It's in the spec, and you need to use the existing OPC UA interface for configuration purposes. But that's fine because that's what people use anyway, right? So in terms of configuring, so what we do at Microsoft obviously is we created like a stopgap solution until all OPC UA servers support MQTT out of the box, right, with a PubSub payload. You need an adapter, right, to connect to all those existing OPC UA servers, which also happen to be all the existing industrial connectivity software. So we created an adapter which basically takes, an OPC UA or connects to an OPC UA server, converts the data to PubSub, and then sends it to the cloud in PubSub format. We call that thing Microsoft OPC Publisher. It's been around for, I don't know, almost 10 years. So it's very popular. Lots of people use it. It's open source, but it's a Microsoft product.
Awesome. Yeah, I think we're going to dive a little bit deep into that, because I noticed recently that you published the manufacturing ontologies reference solution, of which the UA Cloud Publisher is part of that. So I want us to explore that.
So that's a funny story actually, because we started off we started off with that project in the Digital Twin Consortium just to basically create a starting point for manufacturing customers to get familiar with the Digital Twin definition language and then how to use it in services like Azure Digital Twin Service. But very quickly we realized we need more than that. We need like an end-to-end solution that includes ADT, obviously, but also all the other components that you need to be able to model your production line using digital twin technology. So we said we will base the models itself on an existing ontology that everybody in the manufacturing industry should be familiar with. It's ISO 95, right? And we only recently actually completed mapping all, I think it's over 100 different models in ISO 95, and we managed to map all of them to DGL, contributed to the Digital Twin Consortium, and update the reference solution accordingly, right? So we kept adding new components to the reference solution, mainly because of customer feedback. They said, well, how do you integrate this? How do you integrate that? And we said, okay, we'll show you, right? And, it's been really, amazing how popular that repo is. And, I keep getting feature requests for more components that people want to integrate. Just this morning, before we came on the call, actually contributed a tool that came from our field team to use more of the models in a sample, digital twin graph, because so far the reference solution only used the asset hierarchy, which is a small part of ISO 95. But now we got a tool that, you can use material properties, all the material models, the process description models, so you can, model your production processes. Actors are in there, so you can find actors that then interact with either your production line or your automation processes. So there's a lot more in there now than there was originally, and we keep adding new stuff to it. It's funny, actually, I used the Azure Digital Twin Explorer to actually show the model graph, right, of all of ISO 95 with all of, over 100 models in there. And it's quite spectacular what it looks like. So I blogged about it. It was one of my most popular blogs on LinkedIn, right? I got over 45,000 impressions in 3 days. So that was pretty special. So, I mean, obviously there's interest. People like the fact that we support these open standards on Azure. They want these reference architectures so they can model their own cloud solution accordingly. And it's just been phenomenal to get that much, that much positive response for it. So we'll keep making improvements, iterative improvements, little by little, we'll make it better. Yeah. So yeah, it's anybody can contribute, right? It's an open source repo. The Digital Twin Consortium is very open for external contributions. Anybody who wants, a feature, they should open an issue asking for that feature. If they find a bug, send me a bug fix. I'd be more than happy to receive bug fixes, right? And so on, right? So it's becoming a real community project, which is exactly what we intended to do with it, right?
Okay, awesome. Yeah, so we'll certainly be sharing the link to that repo here for our community to check it out and contribute. I'm sure they will be interested to do that.
Yeah, you can even, it's super easy to remember. It's GitHub Digital Twin Consortium Manufacturing Ontologies.
Awesome.
So yeah, and regarding UA Cloud Twin, that's obviously a reference implementation of, OPC Publisher. UA Cloud Twin is reference implementation to build or to take OPC UA PubSub data and then create those ISO 95 assets in digital twin servers automatically as digital twins. UA Cloud Publisher, which you mentioned earlier on, is a reference implementation of OPC Publisher, right? So it's a community version, right? So people ask me, obviously there was OPC Publisher and it's a Microsoft product, but the code isn't that easy to understand because there's a lot of fault tolerance in there. There's a lot of error handling, error checking, all the bits that diagnostics, everything that you need in a Microsoft product, right? So people wanted a simpler reference implementation of an OPC UA PubSub publisher. So I said I'll do that too. The manufacturing ontologies uses the UA Cloud Publisher to keep it generic, right? So obviously, in theory, this solution should run on any cloud, right? Practically, obviously, we've focused mainly on integrating Azure services, of course, but you could easily add other cloud solutions to it if you wanted to, and that's important to the Digital Twin Consortium as a kind of neutral consortium, right? So we made sure that the reference implementation that we have in there is as generic as possible, right?
Awesome. Yeah, so maybe let's kind of linger on that a bit and we'll try to unpack the reference solution. So I know we're going to provide a link and they'll be able to check it out. But while I still have you on the call, I would like to get a sense of your selection of the different components that you have for your reference solution. So I'm actually have it open here. You have got UA Cloud Publisher and UA Cloud Commander at the edge. Could you kind of give us the significance of having, so you've explained UA Cloud Publisher. Can you give us the significance of having UA Cloud Commander at the edge? What is the
Yeah, it's a good one. So, I mean, a lot of people ask how to do a digital feedback loop based on the cloud, right? So some are probably familiar with digital feedback loop, runs in a factory, or a control loop, they call it. A digital feedback loop is sort of like a control loop, but obviously doesn't run in real time. But the idea is that, you collect information from your production line, you send it to the cloud for analysis, you do that analysis, eventually, based on your analysis, you fire an action, right? You create some sort of automated response based on the data that was analyzed. And then obviously you need to send a command or whatever back to the production line to, make a change. Now, this shouldn't be done for safety critical systems, right? Because obviously, it shouldn't rely on the cloud if it's a safety critical component. And because I happen to call this particular visual feedback loop, open pressure relief valve, that sounds like it's safety critical, right? So I got some feedback saying, oh, this is not realistic. I said, listen, just give me a break. It's a sample, okay? But anyway, what it does is it actually calls an Azure function, which is like a command line application running in the cloud that, queries the time series database for a certain threshold value. And when that threshold is reached on one of the machines, it basically says, okay, execute that method. And to execute the method, you need UA Cloud Commander, right? So it's basically an OPC UA client and an MQTT client, and Kafka is also supported. It's also a Kafka client. So it will listen on a certain topic from the MQTT broker running in the cloud. And once that topic receives the command, it converts that command into an OPC UA method call, and then executes the method call on the server, on the machine, to open the pressure relief valve. It's all a simulation, of course, right? So, then in the simulation, the telemetry for the pressure will go back to a normal value, and then the whole thing starts over, right? So it's a way to show, yes, you can complete that digital feedback loop. We have customers using it, obviously not for pressure relief valve, but a lot of times, especially in the process automation space, you have varying quality of inputs or raw material, and you need to update your recipes on a constant basis, right? So the recipe for whatever you're producing, washing powder, needs to be constantly updated. And previously, that was a very time-consuming process where, a chemist would have to take a sample of the product, analyze it, and then say it's good, or yeah, well, maybe we should adjust this ingredient. So that's something you can now do automatically, right? With the help of the cloud, machine learning models help you there to basically react quickly and automatically. And, that way you save downtime, right? You no longer need to turn off your production line while you're analyzing your product. It's constantly analyzed by the cloud, and the cloud automatically adjusts the recipe, right?
Oh, interesting. Now, another component that is really interesting for me is the UA Cloud Library, which happens to be connected to the Asset Administration Shell repository. And can you please explain that significance of having that as part of the solution?
Yeah, so the UA Cloud Library was a project we started in the OPC Foundation a few years ago together with SESMI in the US. So SESMI is also standardized in OPC UA in their reference architecture that's called SMIP, Smart Manufacturing Innovation Platform. And they needed an online store of OPC UA information models, right? In fact, they created a whole marketplace around it. And we said, okay, we'll create something within the OPC Foundation to basically store OPC UA information models in the cloud, make them available for everybody. Also allow a query interface. We picked REST and later on added GraphQL to the cloud library. And there's even a browser now built in where you don't even need to use an API. You can just browse on a dashboard the OPC UA information models uploaded. We have over 100 in there now, all the standardized ones from the VDMA and some from SESME are in there. And it's been super popular actually for and just convenient really if you need to use one of the standard information models, which of course, quite honestly, a lot of people see that as the main benefit of OPC UA, the fact that you have standardized information models for certain machine types, you know. So that's basically the initiative that we started. It's been around for a while now. The working group is still going, but we're kind of focused from designing more to, you know, making sure it keeps running. Obviously, the OPC Foundation hosts an instance. And yeah, I mean, for example, if you create an asset admin shell of an industrial machine, and that machine has an information model in it, right? When you buy it, you know, as an OPC UA interface, then you can just, you know, take, put a reference to the cloud library into the asset admin shell and, you know, automatically download it from there, right? So that's the idea. And it gives you, you know, a lot of benefits. So first of all, you can plan integrating that new machine into your production line before you even buy it, right? You can use the asset admin shell to I mean, the asset admin shell is really a machine readable product catalog, right? So all the properties of the product should be in the asset admin shell, like user manuals and dimensions, and maybe even a 3D model if you want to do CAD design, you know, see if it fits into your production line physically, you know. But also from an integration point of view, you can, you know, download the OPC UA information model through the asset admin shell from the cloud library, from the UA cloud library, and then, you know, integrate that particular information model into your MES system or your ERP system or whatever it may be, you know. So a lot of people use it for that, right? We at Microsoft use it because, as you know, PubSub will only give you the fraction of the OPC UA information model related to the data that PubSub contains, right? But obviously, all the namespace information is in the PubSub message, right? So you can query the cloud library for those namespaces. So basically, you say, okay, do you have an information model for this namespace? Oh, you do, please download it. And then you have the entire information model available, right? And that's kind of convenient if you want to give the user from the cloud, without creating a connection to the shop floor, the possibility to change the telemetry data that is currently getting sent. So it basically gives you like a browse mechanism without having to have a physical connection to the machine, right? So that's really convenient if you're building a dashboard and, you know, you want to say, okay, well, this is the telemetry that you're currently sending. Here's the rest that's also available, right? Awesome. So there are a few use cases like that for it. Yeah.
Absolutely. So I think maybe now let's focus on the distinction between the different data modeling standards. So you've got your asset administration shell, digital twin definition language, and I think at some point I saw one of your work around integrating web of things. Can you kind of like maybe to make it clear for the audience, what is the distinction between these three data models, and what makes them suitable to act in combination as far as the reference solution is concerned?
Yeah, so I mean, there are people out there that think their data model can be used for everything, but that may be true, but usually the performance isn't that great, right? So in general, I think data models should be used for their intended purpose, right? So for OPC UA, the intended purpose is clear. It's for modeling assets, industrial assets. But, you know, a lot of the times I've seen coffee machines with OPC UA built in, right? So, I mean, where do you draw the line? I wouldn't even want to draw the line, but just modeling assets, okay? For products, basically, a product can be an asset, but doesn't have to be. A product can be something else, right? For products, and then also making that data available to your customers, that's what the asset admin shell was designed to do, right? So, of course, if your product happens to be a machine, you will have both. You have, like a asset administration shell for your product that you can make available to your customers. And you may expect your supply chain, to also deliver asset admin shells to you, right? That becomes super handy when you're doing things like product carbon footprint calculations, right? And if you want to make your product carbon footprint available to your customers, right? So that's where the asset admin shell is great. And then, of course, there's Web of Things that is really a data model for defining, things connected to the internet, right? And one thing it does that nobody else does is it creates a description of the endpoint of the thing. So where can I find it in my network? And also the interface that it supports and the protocol it speaks. They call it protocol binding, right? And that's really handy, right? Especially when you're looking at assets that are not discoverable, right? So Modbus is a great example, right? Modbus, lots of assets have a Modbus interface. Well, unless you have the manual handy, you can connect to a Modbus asset without knowing anything about the data model, right? Yeah. So you can use a Web of Things thing description to create a machine-readable version of the user manual, basically, right? And okay, here it is on the network. I can use Modbus to connect to it, and here are all the register addresses and what they mean in terms of the data model. So basically, Web of Things becomes the data model for assets that don't have a data model definition, okay? And we can actually use Web of Things for things like mapping to OPC UA because, there's nothing stopping you from also adding mapping information to OPC UA into that Web of Things thing description. And that's actually something we show together with Siemens. So you basically just add the, reference to the namespace of the OPC UA information model that you want to map to, right? And then in each of the properties, including, the Modbus register address and what it is and how, how many bits, maybe even the unit, is it, a temperature or in degrees Celsius, for example. You can add the OPC UA information model type information that you want to map that particular data tag to, right? And that's what we've done. And we even got ChatGPT to generate the Web of Things thing description automatically, right? Which is super handy and definitely beats typing it in from scratch, right? I'll give you that. I guarantee you that, right? So that's something we're working on right now. Especially with ChatGPT 4, we're making great progress, right? So the idea being is that we can fully automate onboarding those assets that you wouldn't be able to onboard in any other way, right? And obviously onboarding an OPC UA enabled machine is easy because OPC UA has built-in discoverability, right? But for non-discoverable assets, this is really handy. And you can, obviously, if you can generate a Web of Things thing description with ChatGPT, then the rest can be automated completely. So then, of course, with that standardized interface that I talked about at the beginning, that we're just about to kick off a working group for, if we can also say, well, and then the schema for configuring the assets should be Web of Things, for example, right? And then obviously the, connectivity providers will have to be able to parse Web of Things, but picking Web of Things was actually also, one of the reasons why we picked it was because it's so easy to parse. It's just a JSON document, right? Okay. So then you have the whole thing automated. And that's kind of where we want to get to, because I don't know about you, but in my experience, a lot of these industrial IoT projects fail at the first step, which is asset onboarding, right? It's because already say, Jesus, that's a lot of work, right? And then they give up, right? But if we could automate that process, more industrial IoT projects will succeed.
Oh, yeah, absolutely. That's the most crucial part. So, I mean, the project that you've just described, is that part of I know you've got what you call the UA Edge Translator. Is that part of that?
Exactly, yeah. So I'm a very practical oriented person, right? Yeah. So basically when we discuss a new concept, I say, okay, I'll try it out. Okay. And then eventually that proof of concept gets so, let's say, popular that it makes sense to contribute it. So UA Edge Translator really is a reference implementation with a minimum footprint and a minimum functionality, right? It only does Modbus. But to show what this standardized configuration interface for industrial connectivity could look like and how to parse a Web of Things file. I also created a mapping to DTDL. So quite frankly, DTDL and Web of Things are very similar. So you can map back and forth lossless, which is great, right? So some people prefer DTDL, some people prefer Web of Things. Doesn't really matter. If you can translate back and forth, anybody can come with their favorite, schema and we convert internally. So that was the idea with UA Edge Translator, to basically show, look, this is the way, okay? No Star Wars pun intended, right? Yeah. But I mean, please have a look at this. And, seeing is believing, right? So a lot of these things are, so deep, and a lot of folks that don't deal with this on a day-to-day basis don't really understand the problem, and then of course won't understand the solution, right? Because you have to have this kind of end-to-end experience to understand it, right? But with these reference solutions, and I try to contribute as much as I can from these reference solutions that I come up with, to basically show people, look, this is how it works, and then all these this will never work arguments go out the window, right? Because you can show it thrive.
Awesome. Yeah, so I mean, one of the things that you talk about a lot as well is the need for these data model standards to be controlled by IEC or ISO organizations. Mm-hmm. Why is it important for that to be the case?
Well, quite frankly, I mean, you have to have somebody without a commercial interest keeping tap on a certain technology. If you really want broad adoption, you want to have it in the public domain for sure, but you also want to have a control entity keeping track of it or maintaining it, where you can participate if you want, but you only get one vote, right? So there's no one or two companies controlling a technology, right? And that's why standardizing through IEC or ISO is so important, because then, the companies that do standardization basically relinquish control, right? I mean, a lot of times, a company says, okay, we understand that this is becoming popular. We want, to create a bigger ecosystem around it. But, nobody will adopt it if they can change the technology, at a whim, because they control it, right? So you got to relinquish control. You need to basically contribute it to a standards organization and say, we don't walk away from it, but we step back from it and let anybody, participate and make it better. And that's how these standards organizations work, right? So you basically create a task force and you get one vote, and any change needs to get voted on. And then, I mean, if you're the only one who wants to change it, it's not going to happen, right? Yeah. So it's all about building consensus. It's all about, more, I mean, it's like the dynamics of teams. A team will always make a better decision than an individual because you have different perspectives coming together, right? Same applies to standards. If you have lots of different people with different interests coming together and creating a solution for a technology, it's going to be better than a single company making a decision. Yeah, so that's the idea. And that's why usually adoption really takes off once it's a standard, right?
Yep, interesting. Yeah, so I mean, the other thing that I would like to find out from you is around the OPC UA over MQTT, right? So, what do you see as like being the full scope of OPC UA over MQTT in industrial IoT?
Yeah, so I really think because it's a standard, right? It's part of the IEC OPC UA standard. I think it has the best chance of broad adoption. And, we've seen that. I mean, we helped define it 5-6 years ago. We were the first to obviously support it. But since then, AWS, Google, SAP, IBM, Siemens, Beckhoff, I'm sure there's more, started adopting it. And, that really means that, it has crossed that boundary of just one or two companies talking about it, thinking that it's good, to it becoming the de facto standard, right? Or the standard. I mean, it is a standard, but obviously the de facto standard also means the ecosystem has adopted it broadly, right? Oh, Wago is another one. They also support PubSub. And then, of course, you have all the end users. I mean, can't remember how many end users. There's a dashboard that I created for the OPC Foundation for trade shows, which shows, a number of devices connecting through PubSub over MQTT to that dashboard. And I keep having to add more logos to it because it keeps getting bigger and bigger. So, but from the kind of folks offering a cloud solution and receiving PubSub data, all the big ones are there, right? And I know HiveMQ is also now supporting it, which is great. I think next week at OPC Day, there's a presentation from HiveMQ specifically for supporting PubSub, right? Which is awesome, right? Again, the world is a big place. One of the major benefits of OPC UA PubSub over MQTT is that there's two different payloads supported. One is a binary payload, but the more popular one, and quite frankly also the more convenient one, is a JSON encoding. And that means, I can import OPC UA PubSub in every Azure cloud service because every Azure cloud service supports JSON, right?
Yep.
And I don't need to be an OPC UA expert to understand the data because it's just JSON, right? I also don't need to integrate an OPC UA stack into every cloud service. I just need to support JSON, right? And that's obviously an MQTT, right? But that's kind of a given. We obviously now also have, finally, we have a managed MQTT broker in our portfolio, which supports version 3 and 5. So MQTT is no longer an issue, but, supporting this common format like JSON is super critical, because otherwise you end up having to convert the data again in the cloud, and the customer has to pay for that, right? Obviously, the compute needs to be paid for. For what? What's the point in converting data all the time? You pick a format that everybody supports, and quite frankly, MQTT and JSON everybody supports, right? So that's why OPC UA PubSub has seen that broad adoption, because from the start it supported MQTT and JSON. I made sure of that. I was the one who said we need to support MQTT. That was my push, and now look at it, right? So that's one of the big things that I've really seen. You need to kind of pick the simplest possible format that everybody supports if you want broad adoption, right? And I think that's what we did with PubSub, and that's why it's so easy to support it. I worked with a industrial component manufacturer. We did a demo at Hannover Messe, and they had this smart connector. I think I can mention the name. It was Harting, right? So Harting came to us and said, "Hey, let's do a demo together." And I said, "Great," So we integrated the asset admin shell, and I said, "So you're using MQTT to send the data from your connector to the cloud? Yeah, awesome. You use JSON? Yeah, awesome. What format did you use? Oh, we came up with it ourselves." I said, "No, don't do that. Use PubSub. It's a standardized format." And it took them like 2 days to convert their proprietary format to PubSub. And of course, then everything that, we built in the cloud just worked with it, right? It was like hooked up in minutes. And that's the benefit of standardizing on, obviously MQTT is a standard, JSON is a standard, and now with PubSub, we also have the payload standardized. And then, you have interoperability, you have compatibility. It becomes a lot easier to integrate those systems.
Awesome. And what I would also like to find out with regards to PubSub is how does it take care of information model? Right. I think maybe last time I had looked at the standard, it was that once you get that message through a broker, it loses that information model. Is there any measures to kind of like make sure that that model is preserved?
So the broker doesn't look at the payload, right? The broker just shows the message from left to right. So it doesn't lose anything through the broker. But I did mention already, so you don't send the entire OPC UA information model with your PubSub data, right? The information model at OPC UA is usually very big. So as a performance improvement, we said we'll only send the fraction of the information model that is related to the data, to PubSub data that you're sending, right? But what we did do is we split that up actually, so you can send the metadata, so the part of the model that is related to the telemetry, separately. It's a UA metadata message from the telemetry message, which is a UA data message, right? So what we do at Microsoft is we send those to different topics in the MQTT broker. So, the telemetry the telemetry obviously changes all the time. The metadata usually doesn't, right? The metadata stays the same. So you can keep that in the broker, with the retain flag to keep it in the broker. So the idea is any consumer will connect to the broker, read the metadata messages, and then start reading the telemetry so it knows what it's looking at, right?
Yeah.
But that kind of performance improvement that we made for not sending the entire model, that's where the cloud library comes in. And we say, okay, well, if you want the full model, that's already in the cloud, and you can look at the metadata message. And again, it has the namespace URI in there, which is unique, right? So you know exactly where that data, or what that data model looks like, or where it comes from. And then you can connect to the cloud library to download the entire model. Right.
Yep.
And for example, our kind of analytics software on Azure, it's called Azure Data Explorer. It can obviously parse PubSub, right? And we have two different tables set up. It's part of the manufacturing Ontologies solution, so you can have a look at it there. So one table is just for the metadata, one table is just for the data, for the telemetry data, and then you can also import an OPC UA information model for the assets that are sending you the data, right, that you're creating a time series from. You can download that into yet a separate, again, another table from the cloud library. And there's instructions on the GitHub repo on how to do that, right? So then you can, run your queries and again, create those dashboards where you say, look, here's your entire OPC UA information model. These 4 nodes are sending you telemetry data right now. So here's the time series for those 4 nodes. If you want more, configure your edge to send more, right?
Yeah.
That's how it works. So that was a performance improvement we made. The telemetry data that is sent doesn't get lost, right? And the metadata doesn't get lost in the broker. But if you want everything, you can get that through the cloud library. There's actually one additional thing that specifically was a feature request actually from Arlen Nipper. He asked for the type information to also be part of the telemetry message. So the type information is obviously the metadata, but some prefer to have that in the telemetry. So we added that as well. We call that the reversible encoding. So some brokers, or not some brokers, some OPC UA clients that support PubSub have a flag where you can enable reversible encoding. So it adds the type information to the telemetry.
Oh, okay,
which means that in theory, you don't need the metadata, but you do need the metadata to look up the information model, right?
Yeah.
So it's another option. I mean, there's all these options in OPC UA. I mean, it's grown over the years, obviously, and you basically pick the ones that you need.
Yeah.
For your use case. Yeah.
Okay. Yeah, I mean, so to kind of like wind the conversation down, there is one other project that I would like to get your thoughts on. It's the Industrial Metaverse, which I think Microsoft is a part of. Correct me if I'm wrong.
Yeah.
Can you tell us first of all, what is the Industrial Metaverse? What are its use cases, and what is the significance of building it with open interoperability standards?
Yeah, so Microsoft started in the industrial metaverse many years ago. We focused mainly on the augmented reality use cases with HoloLens, obviously being an augmented reality headset. So, for example, remote assisted maintenance scenarios where, think of an oil rig, the person that knows the machine isn't on the oil rig, would have to be flown out by helicopter, so that's expensive. So instead, somebody wears a HoloLens on the oil rig and, creates a video call with the expert, and the expert then sees what the person on the oil rig sees, and then, fixes the machine together with the person on the oil rig. So that's the remote assisted maintenance scenario. So one of the other things the industrial metaverse does well is to create a completely virtual environment. For that, you need a virtual headset, obviously. And that can be very useful for other use cases. For example, for simulating a production line that doesn't exist yet, right? It's in planning. Or, from an existing production line that does exist, but you want to have information at your fingertips in a virtual environment, right? So that's also something a lot of customers are asking for. So Microsoft created the mixed reality toolkit. We open sourced it. So it can handle both virtual reality and augmented reality use cases, which is handy. So it can handle both. But in addition to that, we decided to work with the Digital Twin Consortium and the OPC Foundation to create like a reference architecture where, the whole thing end to end, from the asset to creating a digital twin for the asset, all the way to, creating a augmented reality application or a mixed reality application using the mixed reality toolkit can be shown. So that's what we did. It actually uses parts of the manufacturing ontologies from the Digital Twin Consortium. It's using Unity as a rendering engine. And we contributed it to the OPC Foundation. So everybody can see it, right? And again, it doesn't really matter what kind of headset you have. So I use HP Reverb headset. You can use a HoloLens or any other mixed reality compatible headset, which allows you to see like a wind park simulation, basically. And of course, the idea being is that it uses OPC UA information models. So at Hannover Messe, we had a version of this demo where a standardized OPC UA information model for a wind turbine was used. It's not released yet, it's currently in preview. So there's a working group that currently defines that particular information model, where we could show, look, standardized data in the industrial metaverse using a standardized digital twin. And that's the kind of idea that behind it. It would be a terrible shame and a complete waste of time and energy to remodel digital twins for the industrial metaverse if we can already integrate the existing data models, digital twins from the industrial space that we, have been using all along, right? So that was kind of what we wanted to show, that you don't need to remodel your assets for the metaverse. You just import the existing models, for example, OPC UA, into your Metaverse application, and off you go. That's the idea.
Yeah, that makes sense. Makes sense. Okay, so I mean, do you have any parting words for? So our audience is primarily very pragmatic industrial IoT solution architects and developers. Do you have any advice that you could give them as far as implementing industrial IoT solution is concerned?
Yeah, sure. I mean, look at open source projects. There are plenty good open source projects for industrial applications. Check what's out there. Don't reinvent the wheel if you don't have to. Join an initiative that is already doing something similar to what you're trying to do, rather than going it alone, because you will end up saving a lot of time and money by, you know, building up on top of existing assets and existing data models. And I mean, in general, when you see, oh, well, there's something out there that is almost identical to what I plan to do, you know, stop and consider it, right? A lot of times, you know, we run off and you know, there's time pressure because we're, you know, there's a deadline, but in the end, we're creating, you know, incompatibilities, which then take years to align and consolidate again with the existing stuff, right? So it's better just to pause for a moment and look left and right before you go off and reinvent the wheel for the 100th time, you know? So that's my advice. And again, you know, in general, at these consortia that I've been involved in over the last few years, you have real experts sitting there giving you good advice, right? So it also means that you're not alone, right? It reduces risk because you can run something past some other experts, you know, that will have probably thought of a solution to your problems already, right? So it also is actually a great mechanism to reduce risk.
Awesome. Again, Erich, thank you so much for taking the time to join us today and share your insights with the audience. Really appreciate it.
Well, thank you for having me. It was great to talk to you. Appreciate it.
Thank you.
Thank you.